Welcome to section 3.5. We're going to focus on applications of linear programming here, and there's some great news. The great news is the whole section is summed up in this video. It's just 3 steps. The bad news is that step 1, which is section 3.3, nothing new, step 1 can be very tough. So this whole one is going to give us you more practice. So feel free to go back to section 3.3 make sure my cat's not turning off my computer if you need to get some more practice with that stuff, but we also got plenty of practice for this. Basically, this whole section is just a bunch of examples. So we're going to set up linear programs. Now we're going to use technology to solve them because we're going to be looking at more complicated, bigger linear programs, which are of course going to be more useful as well. And then step 3, we'll make sure our answer is in the context of the problem. So big paragraph. Have you ever wondered why my font's so big? I think math's a little spooky sometimes. I like to make big happy font. You know, math is a lot scarier when it's in tiny font, I think. I like big happy font. Sorry if it's too big. You can always make it smaller. So we have a catering company and they're trying to make lunch for a business meeting. Going to serve ham sandwiches, light ham sandwiches, and veggie sandwiches. Ham sandwich, okay, all right. Sure, we'll write this stuff down. So ham sandwich is going to be 1 serving of veggies. I'll write S. 4 slices of ham. 1 slice cheese. And 2 slices of bread. A light ham is 2 servings of veggies, 2 slices of ham, 1 slice of cheese, 2 slices of bread. So basically the same, but with a little bit more veggies and a little less ham. Let's see, what do we got next? A vegetarian has 3 servings of veggies, 2 slices of cheese, 2 slices of bread, no ham. That makes sense. Okay, so we're organizing this information. We're going to need this information later. A total of 10 bags of ham are available. Total is 10 bags. Each has 40 slices. Okay, so we got 400 slices of ham. I'm just going to write 400 ham. All right, 400 slices of ham. 18 loaves of bread are available, each with 14. So let's see, 18 times 14. I'm not going to do that in my head. I could, I guess. 18 by 14. 252 pieces of bread. All right, 200 servings of veggies. 15 bags of cheese, each with 60 slices. So it's going to be 900 slices of cheese. That's a lot of cheese, goodness. There's no way we're using all this cheese, right? Anyway, how many of each sandwich can be produced if our goal is to maximize the number of sandwiches? So take a deep breath. Whew. What are we trying to solve? To try to find out what you're trying to solve, look at what the question's asking you. How many of each sandwich? That's going to be our variables. Our variables are going to be how many of each sandwich. I forgot to write veggie sandwich over here. All right, so we can let, X, Y, and Z if we want to do it. We could have H, L, and V, ham, light ham, and veggie. Whatever variables you want. I'm a pretty boring guy sometimes. Let's say let X equal the number of ham sandwiches. And we'll have Y be the number of light ham sandwiches. And Z be the number of vegetarian sandwiches. All right, great. Now we're close. So what do we want to maximize, right? That's always what we do next. What do we want to maximize? Well, we want to maximize how many sandwiches they are. We'll call that some total function. And that's just going to be, well, how many ham sandwiches we have, how many light ham sandwiches we have, How many vegetarian sandwiches we have, we just add those up together. That's what we're trying to maximize. What are our constraints? Now we're going to use some new language here that I don't think I used in 3.3. So subject to, it's just like we're maximizing this function subject to the constraints, right? We have to follow the constraints is another way of writing it. This is the very normal math lingo, right? Subject to. Now we just write down all the constraints. Well, we only have a certain amount of ham. How much ham gets used? We have 400 total. 4 slices get used for each ham sandwich. 2 slices get used for the light ham sandwich. And none get used for the veggie sandwiches. Let's write that down. All right, each ham sandwich is going to take 4. Each light ham sandwich is going to take 2. The vegetarian sandwiches, they don't take anything. We don't write anything for the Z. And that can't be more than the total ham that we have available. So this is our ham inequality. We also have other inequalities, right? We have requirements about veggies. The regular ham sandwich is 1 veggie. The light ham sandwich is 2 veggies. And the vegetarian sandwich is 3 veggies. Well, how many servings of veggies do we have? 200. We can't use more than 200. It has to be less than or equal to 200. And we keep on going. We have cheese requirements. All right. So 1 slice of cheese for ham, 1 slice of cheese for light ham, and 2 slices of cheese for the veggies. How much cheese do we have available? We've got lots of cheese. All right, here, I've got a plan. This is a kind of a spooky problem. So what I'm going to do is let's get in the mood, okay? And have spooky math professor. Oh, I'm a ghost. All right. And now you can see what I'm writing behind me now. All right. Spooky section. Let's see what else. We've done the veggies, we've done the ham, we've done the cheese. Oh, bread. Each sandwich takes 2. Ham sandwiches take 2 slices of bread. Light ham sandwiches, 2 slices of bread. Veggie sandwiches, 2 times slices of bread. Right? If we have Z veggie sandwiches, we're using double that, 2Z slices of bread, and we only have 252 slices. Okay, we've done veggies, hams, cheese, bread. Are these the only 4 things? Well, we're also going to make sure that we don't have any negatives. So we're not making a negative number of sandwiches. In the real world, we would also have integer requirements, but that is a much harder problem. So we're not going to require that these be integers. Hopefully they just will be. So this is our setup. So in another color, I'm going to say, this is step 1. This is the setup to our linear program. Now we're not going to solve this by hand. We could graph this region in 3-dimensional space, find all the vertices of that 3-dimensional object captured by these planes, and check the vertices, but we're not going to graph things 3-dimensionally. We're going to use a computer program to solve this, all right? And the way that most computer programs will solve this is with something called the simplex method. You may notice we skipped section 3.4. That's the simplex method. You want to do that by hand? You could. We're not going to. I have done it by hand myself. In a linear programming class, actually. It was its own class that I did this in. It was a very cool class. I love linear programming. It's what got me into math, kind of. So, but anyway, that's step 1. Now we need to solve it with technology. So there's links in quite a few places, Canvas, the homework, etc. Got this handy dandy website. There's some instructions. You can read these if anything goes wrong. If anything goes wrong, follow these notes. Otherwise, we're going to go over here. Now, this may look a little intimidating. Type your linear programming problem below. Press example to see how it's set up. Oh yeah, let's do that. So maximize. Here's our objective function. Subject to, oh, there's the wording again, our constraints. And notice that when it has less than or equal to signs or greater than or equal to signs, they just write less than equals. Just shorthand that's going to work for this program. So let's type that in. See how it goes. All right, so we're going to maximize the total number of sandwiches. We said t was x plus y plus z. Subject to the constraints, now we tab back. 4x plus 2y less than or equal to 400. So y'all will be doing this on your own too. So get used to how this looks. The next constraint is x plus 2y plus 3z less than or equal to 200. Next one is x plus y plus 2z less than or equal to 900. Next one is 2x, 2 across the board, less than or equal to 252. And we need everything to be non-negative. So we typed everything in. Let's go ahead and do a quick double check. T is x plus y plus z. That's what we're maximizing. Good, we got that. First one is 420 and 400. That's how I can like shortcut things in my head. Think, oh, just look at the coefficients of x, y, and z. 4, 2, 0. There's no coefficient, there's no z. And 400. The next one is going to be 1, 2, 3, 200. 1, 2, 3, 200. 1, 1, 2, 900. 1, 1, 2, 900. 2, 2, 2, 252. 222, 252. Great. Let's press the solve button, see what happens. It says we can make 126 sandwiches. We're making 100 ham sandwiches. We aren't making any light ham sandwiches. And 26 vegetable sandwiches. Okay, so let's write that down first in the variables. T, oh, let's go back to a different color. Let's use black. Change the color. So we said T. Wait, I don't think I pressed the right button. We said T is, I already forgot, 126. X is 100. Y is 0, and Z is 26. All right, so we can make 100 sandwiches. Sorry, 126 sandwiches. 100 ham sandwiches. 0 light hams. And 26 veggie sandwiches. And that's 126 total sandwiches. If we want to maximize our sandwiches. This is our answer to the problem. And we want to make sure that this makes sense. Okay? So we box our answer. Let's just do a gut check. 126 sandwiches. Yeah, that's 100 plus 26. Yeah, that checks out. If we make 100 ham and 26 veggies, are we following all the rules? You could check that, right? 100 hams, that's going to be 100 servings of veggies. 26 vegetable sandwiches, that's going to be like 78. Yeah, 178 servings of veggies. Yeah, we had 200. 178, that fits right in there. We're using 400 slices of ham total. Oh, we're maximizing our ham usage. We used all the ham available. Okay. How much cheese are we using? 100 slices of cheese here and 52 slices of cheese here. 152 slices. Yeah, we're only using 150 slices of cheese out of this 900. And then for the bread, 200 slices for one, 52 slices for the other, 250. Okay, so we're using all the ham and all the bread. Most of the veggies, not very much cheese at all. This is the optimal. Great. We're lucky that it's an integer solution, right? We didn't get like 100.2. Things get a little weird. We're going to try to steer away from that in this class, but it'll happen. It'll happen today. Let me know if you have any questions, and this is basically all we're doing. Again, the hard part is all the setup. Once you get this red box, that's not a box. Once you get this red thing, type it in, and it'll give you the answer, and you can interpret that in the context of the problem. Good luck. Have fun.